Solving rational equations with variables in the denominator, Part 2. Question 7. Here we have another rational equation, and there's variables in the denominator position. So I have two parts. Part A asks me to find the values that make the denominator 0. So I'll set the denominator equal to 0 and solve. Now I have an x plus 4 in one denominator, an x minus 4 in another denominator, and an x squared minus 16. So I'm going to set each denominator equal to 0 and solve them separately. If I look at my x plus 4 equals 0, I'll subtract 4 on both sides, and I have x equals a negative 4. X minus 4 equals 0, I'll add 4 to both sides, and I get x equals a 4. Now I have an x squared minus 16 equals 0. This is a quadratic equation because my x is squared. It's also known as the difference of two squares. That's because x squared is a perfect square and 16 is a perfect square. So I have a rule that tells me that I can factor this into two sets of binomials by taking the square root of x squared, so the square root of x squared is x, and then taking the square root of 16, which the square root of 16 is 4, because 4 times 4 is 16. And then, since it's the difference of two squares, I alternate the signs. If you were to FOIL this out by multiplying the x plus 4 times the x minus 4, you should get the x squared minus 16. Now I want to solve this for 0. So I'll take each parenthesis that I found and set it equal to 0. Then I'll solve for x individually. So if I subtract 4 on both sides, I get x equals a negative 4. And then if I add 4 over here, I get x equals positive 4. Now, negative 4 and 4 are just the same as what I already found. So my restrictions are x equals negative 4, comma 4. When x equals a negative 4 or a 4, my denominators go to 0. Since we can't have a denominator equal to 0, that means that x cannot be negative 4 or 4. These are called my restrictions. Part B asks me to solve the rational equation. First, I want to make sure that all my expressions in my denominators are factored. This will help me find the LCD, or the least common denominator. So before, we said that the x squared minus 16 can be written as x minus 4 times x plus 4. So I'm going to rewrite that term with x minus 4 and x plus 4 in the denominator. Now I want to get rid of the denominators in this equation. This will make it easier for me to solve for x. So if I look at all these denominators, I'll see that I need to multiply the entire equation by an x minus 4 times x plus 4. If I do that, I can get rid of every denominator. So I'm going to multiply the entire equation by these two factors. To do that, I need to distribute both of these factors to each term within parentheses. If we look at our first term, we can see that there's an x plus 4 in the denominator and an x plus 4 in the numerator, so those can cancel. And we're left with a 2 times the x minus 4. Now we need to look at our second term. The x minus 4 in the denominator cancels with the x minus 4 on top, so I'm left with an x plus 4 times 1. And that equals a 5x because both the x minus 4 and x plus 4 cancel. Now I need to distribute the 2 to each term in parentheses. So that gives me a 2x minus 8. And then with this term, I need to distribute the negative sign through each term in parentheses. And I don't have to multiply by the 1 because 1 times anything is just that something. So this gives me a negative x minus 4. And it equals 5x. Lastly, I need to combine like terms on the left side. So I have a 2x and a negative x. 2x minus x gives me 1x, or just x. And then a negative 8 plus a negative 4 is a negative 12. So I'll write minus 12, and that equals 5x. Next, I'll add 12 to both sides. And we're left with x equals 5x plus 12. Then I'll subtract 5x from both sides. And we get x minus 5x is a negative 4x equals a positive 12. Divide by negative 4 on both sides. And you're left with x equals 12 divided by negative 4, which is negative 3. So my solution set is x equals negative 3.